This video is about soil pH and salinity. pH is a chemical property of soil, possibly one of the most important ones. It is a measure of the amount of hydrogen ions that are present. The more hydrogen ions are present, the lower the pH and the more acidic the soil is. The fewer you have, the more basic or alkaline it is, and the higher the pH. pH is measured on a scale of 1 to 14, with 1 being the most acidic, 7 being neutral, and 14 being the most alkaline or basic. And this is a log scale, so going from 1 to 2 or 2 to 3 is a 10 times difference. One of the biggest ways that pH affects plants is the availability of nutrients. Here's a chart that shows you the availability of certain nutrients at different pHs. Where the bar narrows means that it's less available. So you can see on the left side, pH of 4, a lot of these bars have narrowed. Nitrogen, potassium, sulfur, meaning that these nutrients may be in the soil, but they're not available. They're getting tied up somehow. As you move further to the right to a more basic pH, you can see that other nutrients become less available, like iron and manganese, boron, and zinc. So the optimal range is somewhere between 5.5 to 7 because that's where most of the nutrients are at a fairly good availability. Soil pH is the problem. You might want to change it. For example, adding lime can help reduce the acidity of your soil. Something that you have to keep in mind though is the soil's buffering capacity. That's its resistance to changing the pH. Soils that have more organic matter and more clays have more surface area and a higher cation exchange capacity. So that fluctuation of the ions may actually neutralize some of the product that you're putting into the soil, and you're going to need a lot more of it to make a change. Acidic or basic soils can develop based on the nature of the parent material, what's in the original rock, and how much rainfall you get. In drier climates where there's less rainfall, the cations that develop as a result of soil weathering, they don't get washed out, and so they're going to accumulate. Those cations end up creating a higher pH soil or an alkaline soil. Alkaline soils can also be developed if you start irrigating the land, because irrigation water typically has some degree of dissolved minerals and salts in it. These soils are generally called salt-affected soils, and there's two major categories, saline and sodic, and some intermediate too. Saline soils usually have a lot of calcium and magnesium in them, and their pH is usually below 8.5. Because of these salts, you may see a white crust developing at the surface when water evaporates. Because it's just the pure water that evaporates from the soil, you're left with that salt on top. The only way to address saline soils is to leach out the salts with a lot of water. And you have to watch out if you're using well water or reclaimed water, because those tend to also have more salts in them. By doing this, the water will dissolve the salts and basically bring them deeper into the soil away from roots. You can also plant more salt-tolerant crops or adjust the drainage so that the water drains away from the plants. The other category is sodic soils, and this is really problematic because it literally ruins the soil. It's characterized by relatively high levels of sodium, and a sodic soil will have a pH between 8.5 to 10 and maybe more. The important thing is that the sodium destroys soil structure. When it attaches to the surface of the soil particle, it causes the particles to be repelled away from each other. The aggregates then break apart, and those small colloids get leached out. They get washed down and they start plugging up the pores of the soil. When that happens, water is no longer able to infiltrate through the soil, and it just kind of puddles on top. To fix sodic soils, what you can do is try to replace the sodium with calcium by adding gypsum, and afterwards you need to irrigate it heavily to try to leach that sodium out of the soil. Gypsum is the most common amendment. There are other products that you can use, but they tend to be more expensive. This is a slow process for fixing the soil because the soil structure has already been destroyed and it has to repair itself over time.